everybody, and welcome to this video. In this video, we're going to have a look at the fundamental counting principle, which is used to calculate the total number of combinations. So we're going to do this counting principle using an example. So let us assume you go to a restaurant and there is a set menu of which you have to choose one starter, one main meal, and one dessert. For starters, you can have veg spring rolls, or you can have a light salad. For main meal, you can have a pasta dish, a burger with a whole wheat brown bun, or a butternut and lentil soup. And for dessert, you can either have a berry cheesecake or a slice of chocolate cake. So the question is, how many different meal combinations could we possibly have? So an example of a meal combination is if you took, for example, spring rolls for the starter, pasta for the main, and chocolate cake. That is one combination. Now you can think it would be quite exhausting to write them all out. So if you say spring roll, pasta, chocolate cake, spring roll, pasta, cheesecake, and then you go on going through the list in an orderly manner until you've counted all ways. What would be much easier is to use the fundamental counting principle. And what that states, if there's P ways of doing one thing and Q ways of doing another thing, then for us to find out how many ways are there in total, it is then the product of those different combinations. So let us do this example. So the fundamental counting principle then says we're going to multiply our different options. So we're going to multiply the number of options for our main, number of options for our dessert, and number of options for starters. So the total number of ways. So first of all, we consider the total number of starters. We have 2 starters. So there's 2 options for starters. For our main meal, we have 3 options. And for our dessert, once again, we have 2. So the total number of combinations that we could have is we can have 2 times 3, which is 6, times 2, which is 12 menus. So there can be 12 different options. So that's the fundamental counting principle, that if we have a certain number of ways of doing one thing and a certain number of ways of doing another thing, then the total number of ways or total number of options is then the product of those ways. So let us have a look at an exercise. So it says, how many outfit combinations are possible from 3 pairs of shoes, 2 jeans, and 4 t-shirts? So again, we're going to use the fundamental counting principle. So we're going to multiply the number of options for our shoes times the number of options for our jeans times the number of options for our t-shirts. Obviously, this question is assuming that everything matches, so it doesn't look funny if you choose a particular combination. But here, how many options do we then have for the shoes? We have 3 pairs of shoes, we have 2 pairs of jeans, and we have 4 t-shirts. So the total number of outfits you can have is 3 times 2, which is 6, times 4. So there's 24 outfits that you can have with that. So the next one says, how many 3-digit codes are possible if you are allowed to repeat digits? So this here is like, for example, a PIN code. How many different PINs could we have? So there's 3 digits, and for us to use the counting principle, we want the total number. So we're going to get the product. So we think, how many options do we have for the first digit? So for the first digit, we are allowed to get put 0, 1, 2, 3, 4, 5, up till 9. So there are 10 options. For the second digit, how many options do we have? Well, we are allowed to repeat digits. So that means we can use a number that we've used before. So again, there are 10 options. And for the third digit, again, we have 10 options because we are allowed to use letters that we have used, numbers that we've used before. So this here is 10 times 10 times 10, which is, there's 1,000 different PIN codes that are possible if with 3 digits, if you're allowed to repeat. Okay, so the last question we have is how many ice cream combinations are possible? So it says you have to choose one of each one. So you have the flavor option, you can choose between vanilla, chocolate, or strawberry, and your toppings, you can either have nuts or you can have chocolate. So again, we have to choose. So the total number will be the product between the flavors and the toppings. So the total number of flavors that we have available are 3, and the total number of toppings that we have to have are 2. So in total, we can have 6 different combinations of ice cream. So for example, we can have vanilla with nuts, we can have vanilla with chocolate, we can have chocolate with nuts, we can have chocolate with chocolate if you're a chocolate lover, we can have strawberry and nuts, or we can have strawberry and chocolate. Now the instruction here says you have to choose one from each one, but if you wanted to have the option of no topping, then you can just add that, because somebody can have no topping, so they can have plain vanilla, and then this would then change to 3 if no toppings are allowed. Let's say you do not like nuts and you do not like chocolate, you would rather just have a plain vanilla ice cream, then you would just then include the no topping as an additional option. Okay, so I hope that you have understood the fundamental counting principle. We'll do a few more examples of counting different things, but please familiarize yourself with these. So when you're looking at a menu or an ice cream list, think to yourself, how many different combinations could you have gotten with all of the options? Thank you for watching this video, and please watch others. Don't forget to subscribe and like. Thank you. Bye.